Availability is pretty simple. We want the people and the systems who are authorized to access the data to be able to access it when they need it. Pretty simple, right? If I can't access something that I need for my work, well, then I can't work. If our e-commerce website is down, well, then we don't have any sales. If we look at the attacks here, it again depends on what their purpose is. Why are they attacking us? What are they trying to gain from this? In the malicious attacks, that could be a DDoS attack. They're trying to drown the connections out with so many connections that either the system crashes or we just can't handle regular transactions. It could be a physical attack. They could drive through a wall to our data center or something else where they compromise the physical systems that we have or hack into them. Or it could just be a disgruntled staff member. If they got passed over for promotion for the third time and now they're angry, they might choose to shut a critical system down. Availability, gone. And just like the confidentiality, it doesn't have to be malicious. It could just be someone doing something that either they're not supposed to do or they don't know they're supposed to do. Regardless, if the web server is down, it is down. It could also be application errors. If an application is written poorly, well, then it crashes. Again, system down. And then hardware. A server can crash. It can just have a disk that dies. The air conditioning can die. Power can be out. Internet can be down. Can cause our data not to be available. And as with anything else, we have the appropriate amount of countermeasures. I'm going throughout this course to be using the example of $10,000. I have $10,000 on my table, or I have data that's worth $10,000. How much should I use to protect that? Well, it doesn't make sense to spend $100,000. The same with the availability. If you go down and you ask senior management, how much uptime do you want on our e-commerce server? They're going to say 100%. Never want our server to be down, ever. And we can do that. We can have it up all the time. But what if it costs $100,000 or $1 million? Is that worth it? And this is really where your job is. You need to translate what senior management think they want into what does that actually mean. Maybe they're happy with 99.999% uptime. If they're happy with that, and we can do that for $10,000 or $50,000, well, let's do that then. So going back to availability, we can use intrusion detection and intrusion prevention system. They are what they sound like. A detection system detects the attack and does whatever it's programmed to. That can be alert someone, that could just be start a blinking light or whatever we have it set to. Intrusion prevention system can do the same, but it might also take action. It might black hole the traffic, it might sever the connection, it might do something where it prevents whatever is happening. The danger then here is, yes, it prevents something, but what if it is a false positive? So intrusion prevention systems needs a lot more tweaking. Then we have patch management. If our systems are patched and up to date, they're less likely to be compromised. If you remember the big hack where Equifax was breached and they lost 150 million social security numbers, I think. So basically half the American population got their social security numbers compromised. That could have been avoided. 2 months before that breach, there was a patch out for those systems. And that's the tricky part with patches. When the patch is out, then the attackers know there's a vulnerability, which also means they now know which systems to attack how. But for whatever reason, Equifax chose not to patch their systems. They had 2 months. And we don't just go in and patch the systems as soon as the patch is out. We'll go in, we test them in our test bed on similar systems or exactly the same systems. See if it breaks anything. Look at what other people are experiencing with this patch. And once all that's done and we're good and we're happy, then we implement it. But we don't wait 2 months. And another thing that can help us tremendously with availability is redundancy. You can have redundant systems, redundant hardware, redundant connections. So if you have a critical system, maybe you have 2 servers in separate data centers that does load balancing. If one dies, the other one takes over, does all the traffic. Obviously, they both have to be spec'd to run all the traffic by themselves. And most servers, when you buy them, they have multiple power supplies Each power supply on its own can run the whole system. In the data center, you have multiple UPSs, you have multiple generators, you have multiple HVACs. So if one component dies, everything is still fine. Or at least you're supposed to have that. I have worked in a data center where we had enough power, we had enough UPSs, but because the server team were lazy, they put the majority of the servers on one side of the room, which you can do fine if you run the power cables. They did not. Each side of the room had 2 UPSs. The left side of the room, I think, was at maybe 120% of one UPS, the other side 60%. With 60% failed, no problem. That's one UPS can take it 60% easy. Other side could not. So when someone, by mistake, shut one UPS off on the side with 120%, then all of a sudden, the last UPS left was 120% load, and to save itself, it shut itself down, meaning 2/3 of the entire data center was out. That is what we call an RPE, resume producing event. Do not do it. We could also on our systems use RAID, meaning we have the data on multiple disks. We can either do that with mirroring or striping. Either way, we built the system so if 1 or 2 or 3 or however many hard disks we want as redundancy fails, then the system is still up. Most systems today have hot swappable hard drives. You can get an alert saying disk number 3 on this server is predicted to fail. Then go down, you pull the disk out, you add a new disk, and problem solved. We also want redundant traffic paths. Servers, again, have multiple network cards. They should go to 2 or more different switches that is connected to 2 and more different routers that are connected to 2 or more different ISPs. If one ISP goes down, or the router, or the switch, or whatever point in that network, if anything fails, we still have a connection out on the other path. So you can see redundancy, redundancy, redundancy. And of course, we design it where it makes sense. If we have a server with, access databases that are used for reports every 3 months, we might not want so much redundancy on that. It doesn't make fiscal sense. But if we have a production server, let's say patient data at a hospital, well, that is critical. We need that up all the time, no downtime. Here, we would have the multiple servers. They would have multiple power supplies, multiple network cards, RAID, different network connections, UPSs, everything would be redundant. So if, for whatever reason, that one server dies, we are still good. I hope that was not too much ranting about availability. But since these 3 are such core principles that are going to go back to everything else we do the rest of this course, I think it makes sense to go a little more in depth here and be very clear on why we do it and how we do it. So now that we're a little more clear on the threats and what we can do to prevent them against the CIA triad, let's also look at how they work together. Because as mentioned, we need the right mix for whatever we are protecting. With my website, confidentiality is not a huge problem as long as it's not personal data. If it's come by my stuff or read my blog or whatever, well, then I don't want it to be confidential. I want the integrity to be right so that whatever it says on there is true, and I want the availability so people can access it, but the confidentiality doesn't matter so much. And this is where, in its essence, IT security is. It's the right mix of these 3 to protect whatever you're protecting. If we have too much confidentiality, if it's too difficult to get to the data, then we have less availability, which in some cases is fine. The same with the integrity. If there's excessive integrity checks on the data, it's going to slow down and you might not be able to use it how you should. And as you can see, this is how the integrity and the confidentiality are tied closely together. If we have too much availability, then both integrity and confidentiality can suffer. And let's close out this lecture by looking at the opposites of the CIA triad: disclosure, alteration, and destruction, or DID. For most things in IT security, luckily, things are what they sound like. Disclosure makes sense. Our data is disclosed. It's the opposite of confidentiality. Someone who is not supposed to be able to access that data gets access to it. Alteration. They're altering our data. Again, the opposite of integrity. We may or may not know what they changed or that they changed anything at all. And then finally, availability, destruction. And destruction does sound a little harsh, but if our data or our systems are either destroyed or rendered inaccessible, well, then it's destruction. If a DDoS attacks bring my server down, then at that point, the data is not available. We can't use it how we should. On the exam, I don't think you're going to get any definition questions that is confidentiality or integrity, because they really are the basis of IT security. You might see something where it describes a scenario, and then we have a message, we encrypt it, we digitally sign it, then what do we have here? And then the answer options will be confidentiality, availability, integrity, non-repudiation, authentication, in some sort of mix. And then you need to understand both how encryption and digital signatures work to pick the right answer. And in this case, if we encrypt and we digitally sign, then we get confidentiality, we get authentication, we get non-repudiation, and we get integrity. At this point, this is not something I would expect you to know, because we have not covered encryption and we have not covered digital signatures. But just understand the CIA triad is so fundamental, it is going to be something that you need to understand throughout the entire curriculum. So really, anything you learn from here on out, think, how does this apply to the CIA triad? And with that, let's move to the next lecture.